So I'm Matt Johnson. I've talked to a lot of you online on the RavenDB Google group. You might have also caught me on Stack Overflow. This talk's going to be on date and time in RavenDB. Besides RavenDB, my other big passion is date and time issues in general. So if you ever have any of those in your business logic, feel free to hit me up online. I am also doing a Pluralsight course on the subject, which is not in the catalog today, but should be in the next couple of weeks. I wanted to talk about date and time in RavenDB because date and time in databases in general is something that is often glossed over. And I'm not going to talk like time series database stuff that Oren was in earlier. Although I might pick on him a little bit. There was a daylight saving time bug in what you demoed earlier. So I'll be happy to talk about that in a little bit. But let's just kind of talk in general about date and time. So I'm going to give you 3 general rules for date and time. And I'm going to try to keep them brief because I could talk all day long on this subject, and I really want to get to RavenDB specific. So these first 3 are going to be very general, and then we'll jump into the Raven after that. So in general, rule number 1, avoid DateTime.Now. This was your mistake earlier. So there's a lot of problems with DateTime.Now. The purpose of DateTime.Now, the one spot you should be using it, is when you are writing a Windows desktop application and you want to show the clock to the user on their own PC. That's really all that it's for. If you use it for any other use case, what you're doing is you're involving the time zone settings of the computer that your code is running on, and you're also potentially creating ambiguous information. Because of the nature of daylight saving time, there is, at least in many time zones that support daylight saving time, there is an hour a year where there is a gap of information, and there's an hour a year where there's an overlap, where the exact same point in time could actually be referenced by 2 different values. So yeah, time is relative. If you're using RavenDB, you're probably writing a server app. Not necessarily. You could be using it in embedded context, and maybe there's a use case there. But in the 90% use cases, you want to avoid DateTime.Now. Exactly. Whose now are you talking about? Well, we're still sitting here in the conference and it's the middle of the day, so I guess there's not really a bug in what you wrote as much as there would be if you put that into production. And then we were tracking people's heartbeats, right? So I guess in the middle of the night on the March 9th in the US, or March 28th in Israel, or March 30th in Europe that just happened, we'd actually find that we were dead for an hour. No heartbeats at all. Not during the recording, but when you went back to analyze the data later, you'd be scratching your heads trying to figure out why there was a gap in your time. And of course, in the fall, it would look like you had arrhythmia. This is a big one. What if you move your database to another city? Companies do relocate, and they usually take their IT infrastructure with them, or they keep it hosted where it is, but they start changing all kinds of settings. If I was located in New York and I'm moving to Los Angeles, I don't want to be pulling with me date and time information that's localized, because it's going to have different meaning. What I recorded in the past is different than what I'm recording right now and the way I'm looking at it right now. The cloud. Most cloud environments keep the time zone of the cloud servers at UTC. It's good because you'll catch that almost right away, unless you are in London in the winter, and then you might not notice because it'll just happen to match your own time. But for the most part in the US, you'll notice right away. It's actually a good thing because it avoids a lot of other little nuances, and you should just be prepared for that. Not necessarily, though. You could be in a cloud environment where you've got your own VM infrastructure and you have control over your time zone settings. But on every Windows computer and most Linux computers, the time zone setting is global. Only in environments like Java or PHP do you actually get a time zone setting for your app. In .NET and a whole bunch of other languages, the time zone setting is always for the entire machine. And it's not really something as a developer you have control over. It's something your IT infrastructure people would be doing. If you're a DevOps and you're in control yourself, then you've got some control, but it's a very easy thing for somebody to just click down on the taskbar and change it, and now they've messed up your data. But Matt, I don't care about time zones. I hear this all the time. I really don't care. I just want to get through my app, and I've been doing this for years, and it's no problem, right? You do. Most people do. If you're lucky enough to live in Hawaii or Arizona and you're only ever dealing with your own local time zone, then maybe you don't have to deal with this issue. But most people want to deal with daylight savings time, and most people have to deal with aggregates. Aggregates are interesting in RavenDB because we do things like run daily report totals. I want to see my sales totals for last week. I want to see my future projections for tomorrow and the day after that and the day after that. Anytime we use these terms, we're boxing ourselves into a time zone. Some time zone somewhere. It's a localized context. And you don't want to be implicit about this context. That's the problem with DateTime.Now, is it implicitly reads the time zone of your own machine and applies it to your data. If you're going to be dealing with data coming from lots of different places, like most of us are at the internet, you want to be explicit about that context. So in .NET, when you want to get the current time, you use DateTime.UTC now, and that'll always be related to UTC. Or you can use one of the DateTime offset methods, DateTime.offset.now or DateTime offset UTC now. And what that does is it records that context in the value that you're dealing with. So you're not being implicit about it. And we just talked about daylight savings time quite a bit. That's the main reason to run it locally. Key takeaway on rule number 1, a point on a calendar is not necessarily a unique point in time. It has to be qualified by some context. Keep that in mind. I'm going to get through these real quick. Rule number 2, context matters. More on what we were kind of talking about, but this is a little different point of view. So first I want to talk about scope. So can anybody tell me what we usually do in .NET when we're talking about something that happens for the entire day? Like, how do I get the current day? DateTime today, there we go. You know what that does? DateTime.Now.date, which essentially is DateTime at midnight. It's not the day, it's not the entire day, it's the point at midnight of the morning of that day. So date and time versus date only is a big problem because of 2 reasons. One, going back to daylight saving time issues, not every day has a midnight. If you are in someplace like Brazil or several other places in Africa and a few in the Middle East, they transition their daylight savings right at midnight. And when that happens, you never hit midnight exactly. You go from 11:59:59 to 1 o'clock. So you say daytime today, and you get back a datetime object that doesn't really exist on that local calendar. So it's lying to you. If you store that in your database, you're going to store all those zeros, and it's going to look like you just took the time at midnight. Who's there to tell you that you should be ignoring the zeros? Nobody. There is no date object in .NET, at least not natively. So you have to be aware of this issue, and you have to compensate for it. Time of day versus elapsed time. So when you do DateTime.Now, or really take a datetime object at all, there's a .time of day property, and that gives you back a time span. But actually, a time span is not a time of day. A time span can go from negative many hundreds of days to positive many hundreds of days, and it's something you use like a stopwatch timer or to reference a point on a timeline. It's an elapsed measure of time. It's not a time of day. The time of day is a very sub-focused part of that, from 0 to 23:59:59, and can't go negative. And also, it is repeating cyclically. When you are at 2300 and you add 2 hours, you should be at 100 because you've skipped over that date boundary. The time span object does not represent that behavior. You have to be aware of that. Also, this comes into play with like field validation. So if you just say, well, validate that the data the user's giving me can fit into the type that I have, they can put a lot more data in there, and you might save it to your database, but then your math's all going to be wrong. And again, more daylight savings time issues. And then lastly on that subject, keep in mind that a time span is a discrete unit of time. So if I say something is 90 days, that's not the same as saying it's 3 months. There actually is no type in .NET out of the framework that can represent 3 months, because it matters which 3 months. You know, as we all know, there's different days to a different number of months, which means there's a different measure of time. And really, it's not just months, it's also years because of leap years. And it's even days, because on a calendar, not every calendar day is 24 hours in length, because again, of daylight saving time. You could have 23, 23 and a half, 24, 24 and a half, or 25 hours. And the halves are only valid on some certain islands in the South Pacific. You gotta love this stuff. Okay, second part of context is what I call perspective. The datetime object calls this kind. There's a datetime kind enum, and there's a kind property on a datetime. It has 3 values, unspecified, universal, or local. Actually, they say UTC. They're really talking about a universal perspective, which could be measured in UTC, but that's more technical than I want to get into right now. These are important. When you just say new date time, you aren't talking about any particular calendar. You're talking that it's unspecified. So year, month, day, hour, minute, second, somewhere. And when you save that into JSON, you get a nice ISO-formatted time string with no context whatsoever. So you say that to your database, you've got to look at the end of that string. If there's no Z or offset information, then you don't have a discrete reference back to a distinct point in time. So be very careful with unspecified. They do have their place. There are lots of things where you don't want to track context, or you've got context implied in other parts of your domain or stored in another variable. Unspecified has its use for that. Universal is what you should be using most of the time. In fact, in RavenDB, just to make sure that universal time is used throughout, we actually have a class called system time, and you can say system.time.UTC-now, and it kind of makes sure that you are getting back the UTC now. That's available on the server side only, I believe. I don't think that's in the client. But even if it's not, that's something you can do yourself pretty easily. I could be wrong on that. It's abstractions. OK, that's good. And it's kind of nice because it has a func where you can override your own settings, and that actually makes things easier to test. So if you've ever been in a unit test and you're trying to test things that are time related, but yet time is elapsing while you're doing it, or you wrote the test and it passed, and then a month later it fails, it's because you're taking a dependency on the system clock. You really should think of the system clock like a service, just like your database. So you can either override the behavior like we do in RavenDB. In other projects, you might take an abstraction on a clock interface so that you can mock that interface. There's lots of different ways to handle that. Local is the one you want to avoid. There are just too many different locals. If you just say it's local time, you're not being specific enough, and that can cause all kinds of problems in the logic of your data. All right, rule 3, and then I'm on to more Raven-specific stuff and code. Rule 3 is when I say on Stack Overflow about 10 times a week. People start posting, my time zone is -700. No, your time zone is Pacific Standard Time, or your time zone is Pacific Time, actually. Your time zone is not -700 because it's only -700 in Pacific Time during daylight savings, and it's actually -800 in the Standard Time. So this differs all over the world. There's multiple time zones that share the same offsets. An offset is just about how do I relate to UTC for that particular moment. So this datetime offset object that we all have started to use and get to love, it locks you into being very specific to a moment in time, but it does not lock you into being in a particular time zone. If you ever change the time associated with that, you don't know that that offset is the same correct offset for what you've changed. Time zones have more information. We have a name or an identifier. In the Microsoft Time Zone database, you have names that are a little confusing. You have things that say Eastern Standard Time, and really they mean Eastern Time composed of Eastern Standard Time and Eastern Daylight Time. So you have to be aware of those little nuances. There's another set of identifiers that's published by IANA and is used in Linux and Java and PHP and a lot of other places. And those look like America/New York or America/Los Angeles, where you have a country name and some corresponding city that is the reference point for that time zone. You can do those in .NET through a project called Noda Time. And I'm going to talk about that a little more in my demo. Time zones always have a standard offset, and they might have a daylight offset if daylight savings time applies. The transition points vary drastically. DST is not a worldwide phenomenon, and it's all up to the individual governments where it applies, if it applies, and how it applies. Changes all the time. There was a RavenDB webinar that we all missed by an hour because Israel changed their time zone rules, and Israel did it properly, but Citrix did not keep their time zone database up to date because Citrix is running Java, and in Java you have to run TZ Updater, which is out of band from the JRE, and they didn't do that, and they're on and on and on. Nonetheless, we all missed our meeting. So don't think that your DST rules are the same as others. Europe just had theirs, March 30th. A few days before that was Israel's, because theirs is on a Friday, not on a Sunday, because of the way that weekends work in Israel. And in the US, it was on March 9th, several weeks before that. Time zone history changes. You can't go back in time. Time's immutable. So we always say that we'd love to get rid of daylight savings time so we don't have these issues. Well, guess what? We will never get rid of it because it happened. We can get beyond it, and at some point in our data, we will no longer be referring back to prior data. Some people keep records for 7 years or so, and then they forget about them. So if they abolished EST tomorrow, then it would probably be 7 to 10 years before we could forget about it. But not really. This is a datetime offset. It's a datetime offset serialized in the ISO 8601 format. This is what RavenDB uses, except RavenDB puts a bunch of extra decimal points on the end because we want to retain the precision of the objects that .NET uses. .NET calls things ticks, which are 1/10,000th of a nanosecond. 10,000 ticks in a nanosecond. Sorry to say that. So very, very fine precision. But the actual Windows system clock is nowhere near that precise. So when you see all those decimals and stuff on the end, don't fool yourself. That's the value read from that clock if you took it from your computer's local clock. Now, maybe you didn't take it from your computer's local clock. Maybe you took it from a dedicated piece of timekeeping hardware. And this does happen, especially for sensor measurements that are being read under high precisions. So that's why we have the capability to support that precision. But in Windows, really, you can't trust it for more than 10 milliseconds or so. Earlier, we saw Allende in a tight loop, pulling DateTime.Now in a tight loop. Usually don't want to do that, but the reason we didn't see the value change is because Windows has some interesting stuff happening in the background to make sure it's not reading from the clock more rapidly than it needs to. Even though it's only accurate to 10 milliseconds, if you call it 100 times in a tight loop, longer than 10 milliseconds, you're still going to get that same value back. You have to get quite a bit longer than that, and I can't remember off the top of my head what it is before it'll tick over. So be aware that your own clock isn't super precise. It's all based on these little cheap crystals that go on your motherboard. That's a time zone. That's an offset. Don't get them mixed up. Eastern time is EST and EDT. It rotates back and forth. Windows, I talked about Eastern Standard Time, IANA, American, New York. The standard in the Windows ID does not mean that you always stick to standard time. It just means that that's what Windows calls that name of that time zone. Confused? Like I said, I'm putting out a Pluralsight course. It's about 4.5 hours, so this was just a very quick hash through. Some of the issues you need to be aware of, and they are contextually relevant to your data. I'm going to do one other little demo here. This is a slide I've put together in a few different places, and it's kind of a visual analogy of how to help pull together all this weird information about time zones. And it's a good just thought exercise, even if it's not for code. So let's imagine that something happened. We've got little Elvis Clippy here from Office, and he's doing something. So there's an event that occurred at a specific point in time. We have this instantaneous timeline that is continuously moving forward. The universe has its own rules about time that we can't control, and we're not talking about Einstein relativity theory or anything like that. We're just talking about, like, click my fingers, that happened at a specific discrete point. But we, as humans, have our own ideas of calendar time. And if I'm taking a picture of this guy doing his event, I'm taking on a local temporal context. I might not be thinking about it, but that's what I'm doing. So here in Eastern time, that could be 7 o'clock or 8 o'clock, because there's a 1-hour difference when daylight saving time happens, depending on when that event falls. And I'll assign that an offset. So we say -5 or -4, and that's how far east or west from UTC we are. But other parts of the world, this one happens to be Israel, they take it at different times, either +2 or +3. I really like the camera analogy because you notice they're holding their camera, so it's like your hand's shaky, you can't really control it. But really, the cameras are controlled by the rules for DST that all these governments change their mind about all the time. It doesn't change when that point in time happened. We label our cameras with the names of the specific time zones. So we call them Eastern or Israel or whatever identifier we're going to associate with it. And that's important because there may be other cameras positioned at that exact same point that have different rules about how they maneuver, right? So if everybody's with me, from the perspective of Elvis Clippy over here, he can see lots of different places where that event, people are recording his event, but yet it's only happening at a single point in time. Then we have UTC, and that's like on a tripod. It's fixed. It can't be changed. So that's why we align everything to UTC. This is not taking into account leap seconds and other stuff, but that's a talk for another time. So with all that information in mind, what we get out of that on the right, now I omitted the date part of that, because normally this would be fixed to a particular date. But you can see here, just on this one chart, I've got 5 different local date time offset references, or here a time offset, for that same instantaneous point in time. So when you look at a date time offset value, it's telling you, if I go back to the, where is it? That one there. It's not telling you subtract 4 hours. It's telling you that that value has already been subtracted 4 hours from UTC. So if I want to put that back at UTC, it's not 1100, it's 1900. You invert the sign and then apply it. So let me get past this. And I think we're actually on to RavenDB. Show me the code. How am I doing on time? Good? OK. So I've got a few different code demos that I put together. Let me just zoom in. Hopefully everybody can see. I want to start out with a very, very simple sample here. So here's a typical class that has a date time. This is a sales order. I like to call it sales order instead of order just because link order by and not having that conflict. And I've got the date ordered. Now it's a date time, so I do this interesting naming convention. I really like to make sure that if it's a date time, I qualify it because I don't want to accidentally forget that it's in UTC. So I always put date ordered UTC if I'm using date times. So we're going to do a few different things. We're going to populate some orders, and I'm going to show you just really quickly how I populate those. So opening a session, and everybody see this OK? Saying new date time, and I make sure I pass date time kind UTC. OK, so this order happened in a particular instant. This is basically what you'd be doing from a website is you would be calling datetime UTC now and passing that into your variable. But what I'm doing here to populate some test orders is kind of what Oren was doing earlier by adding time, except I'm adding a random amount of time because I really want these orders to represent something you'd have closer into real life. So I'm putting a random amount of sale and a random customer name and separating these orders by a random amount of minutes. So I'm going to do enough to cover this time period. So I'm basically starting in January, and I haven't set it to say insert 10,000 orders. I'm saying insert orders for a random amount of time until you achieve today, at least by UTC. So populating those orders, we're going to use that same example over and over again, so I'm not going to keep repeating myself on it. I'm basically going to run some queries. Okay, so I basically want to say, give me all orders for the last 10 orders here for last month. So one of the things I'm doing in this is I'm doing a range query. So notice I'm saying start of last month, and I'm using greater than or equal to. The start of this month, I'm using the less than. So this is what we call a half open interval. And if you pay enough attention, you'll notice that humans do this naturally. If we say an event is January 1st to January 2nd, we really mean 2 whole days. That's a completely closed interval, right? So we say that would be a 48-hour period that elapsed if we say it's 2 full days. But when we give it a time, if I say 1 p.m. to 2 p.m., I usually don't mean 2 p.m. I usually mean the event is over at 2 p.m. So that's the way to think about it. If there's a time involved at all, the ending part of that range shouldn't have an equal sign on it. That will allow you to back things up one next to another and not worry about something that happens right at that moment being in 2 different periods. Another approach some people like to take is to subtract a millisecond. You'll see like to 2359, 59.999, whatever. But then when you do math on those things, you're off by a millisecond, and things don't quite line up, and then you got rounding errors and et cetera. So try to remember that when you're doing range queries, you want to be using half open ranges when you're talking about time, and you want to be using fully closed ranges when you're talking about dates. So I'm going to take some items here. Basically, I'm just going to take a page coming out of here, and I'm going to sort them by date. So let's just kind of see what this looks like. Demo 1, get last 10 orders run. And unfortunately, I don't have enough screen space, but kind of run through this. Now, just for sake of demo here, I'm just dumping these out in JSON. And I've wired up the JSON serializer that Raven uses so that I can show you exactly how Raven stores date and time. Really what I'm getting back is JSON that's been serialized back to C# classes by Raven. by the Raven client. And then I have to serialize them back to JSON here for display for you. So if you're not careful to use the Raven serializer exactly the way it's been configured by Raven, you won't necessarily see the exact way that it displays in the database. Another way to do this without all the fancy tricks is just to pull open Raven Studio and look at your document directly, because there you're seeing it as the string of the JSON that actually exists in your database. So we see this long format here. And this, again, is the ISO 8601 format. And you can recognize it by this T in the middle. And the Z at the end is telling us that it's in UTC. The Z stands for Zulu time, and it goes back to military custom of putting an alphabet to different time zones, which only really holds up for UTC because of the way all the time zone changes work. But you'll see here, I've got all these extraneous zeros, and that's because of the precision of the datetime object that I serialized. You need 7 decimal places in .NET to be able to fully round trip that and not have it be a different value. So I've got a whole bunch of orders here, and I'm just taking the last 10, and you should see these are pretty much in sequence. I've got another test that we can see here. Those are the last 10 orders. Here's the range query that says for the last month. Take a little while because I'm repopulating the orders every time, so the data is not going to line up here. This is the Lucene query that actually gets executed. Let me move this over so it doesn't wrap. So here's the output, but this was actually the input. So when I built that range query, you notice here in Lucene, I've got square brackets, and it says to null. And then I've got star to whatever. So this is basically setting up this as the fully inclusive side, and this as the exclusive side. The syntax variation is specific to Lucene. And I believe there's something in progress. What we'd really love to be able to do is just condense that, get rid of that part and make that a single fixed. Oren says fixed. Okay. Sorry if this is bumping. So that would be just an optimization to make, but basically Lucene kind of combines these right now and to give you this range aspect. So everything's good here, except this isn't the end of it, because really in real life the answer isn't just use UTC for everything. I have that argument quite a lot with people because a lot of developers, they just jump to what they've been taught of always store UTC, always display local time. That's short-sighted, and it's not exactly what needs to happen. And I'm not going to give you a direct advice of what you should do here, other than to say you need to think about the context that you're in. You need to try to figure out what makes sense for your particular scenario, and every scenario is going to be different. There is no one right rule. So what did I do wrong in this, other than making the font so big? The main thing I did wrong, not the last 10 orders so much, because here I'm saying, OK, I just want the last 10, so I'm sorting them by the date and taking the top 10. That's not so bad. But when I had the one to the range query, look how I'm getting the time. I'm saying DateTime UTC now, and then I'm saying the start of the month is based on the UTC time. Now, is that really how we want to be writing our application? Do we say we align, our month doesn't start until it starts in UTC? That's not what typically happens in the real world. What typically happens in the real world is that we have some other context. We have a time zone. We know that the user of this data has a particular expectation about what that data is representing. Now, that user could be a salesperson in a central office that wants all the data materialized to that. Or it could be a customer in their own local time zone because they want to see what orders they placed for last month. Those two things might not necessarily line up perfectly. Right on the edge, there could be some overlap. If you get a customer that places an order and says, well, it's not on my orders list for last month, or more likely you're on a bank statement where you're trying to say, I need to reconcile my statement for the month. That's probably more accurate. But the bank says, well, it's on our records for this month. And the guys look, well, actually, it's on my records at the end of last month. Well, that's why, is because context is different based on the observer. There's a lot of interesting tricks you can put yourself through to try to figure out what the right context is. Not worth getting into at this point, other than to say you should probably be thinking about it. Let's pull up the next demo. So I have to remind myself what the difference between the demos was. This one, I'm still using UTC, but I'm going to do a map reduce. what I want to show you here is how to aggregate data that has time in it. So I'm pushing out the same information that I did before, but here I'm aggregating it by date. And again, this is slightly wrong, because in real life, we don't all align our dates to UTC. If we did, then we would be waking up in the late hours of the evening and going to bed in the early morning, at least in the Western Hemisphere. So it's important to realize here that even though I was storing UTC, I don't necessarily want to aggregate by UTC or query by UTC. I'm not even going to bother running this. It will get the correct results. And you can see here, this is your basic map reduce, count by one. I'm using the date property to actually do, this was a shortcut just so I can kind of show you. That is date equals. I could just say that. But if I just said, well, it's the fields, then I'm not bucketing it into the right aggregation. I'm not saying it's daily, right? You could do it here, and then you could put the .date here, and that would do the same thing. I typically like to do it in the map. It tends to make more sense and make life easier. Plus, you get this nice little convenience of being able to pull off that implicit field because they line up. That will give you daily totals, but again, they're not aligned to your perspective. So let's kind of look at how we would do that. I'm going to use this DateTime offset object instead. And notice I dropped the UTC extension from date ordered. So DateTime offset is what I showed you earlier, where the end of the string has a amount of time that tells you how far away from UTC it is. It can go from minus, I think it's not 12, I think it's either 13 or 14, and there's some that go positive 14. I can't remember which one it's on, but there's some that actually go across the date-time boundary in the middle of the ocean, the international date line. But the fact is that it's variable, and they're not always in whole hours. There's plenty of time zones that use half hours, and there's a couple that use 45-minute offsets. So the half hour one you'll see all the time because of places like India that are permanently fixed to 5.5 hours ahead of UTC, so plus 5:30. But you'll also, if you get into more obscure parts of the world, Nepal is plus 5:45, and there's a couple cities in Australia that are plus 8:45. So you really can't normalize to the nearest hour and expect it to work for the entire world. If you don't care about those few remote places, you could jump to the nearest half hour. Otherwise, you've got to go to the nearest 15 minutes. Really, you shouldn't be thinking that too much other than to know that there's a variable bit of information in here. So what happens when we store this? Pretty much nothing. In my populate method, I am, let's see here. This order date is not what I'm actually storing here. Let's see. Oh, OK, so what I'm doing in this one is I'm basically saying, give me a time zone. So this is saying that user is in some random part of the world. And I'm still iterating through UTC because I'm talking about just building out some random data here. But then I'm building a date time offset. So I'm basically pretending that these are users from all over the world putting in different date time offset values. So I want to run this so you can kind of just see what I'm looking at. Not for last month. I want the last 10. Pull this up again. You can't tell by me moving things around. I'm very much used to multiple monitors. So here's exactly what I'm talking about. So, I've got a different bit of information at the end of each one of these. And that does two things for me. It makes sure that I know the context. I know what exact moment in time this is. But it also means that I know what local time it was. For this guy, for David, for this sale, it was 21:33, his local time. So it lets you do all kinds of interesting aggregations. If I want to know things by the unique point in time, I can do the conversion and then aggregate. If I want to know things by his point in time, I can aggregate and then do the conversion. So it gives you options. That's the main advantage using data offset is you get more options opened up to you. You don't get locked into doing it one way or the other. I want to run this, but I also want to show you code. So that was just populating some random data again. There's orders for last month. And in this one, yeah, where's the one I'm using the index on? Oh, I don't have an index here. So this is all dynamic. So session query sales order, right? So I didn't define an index here. I'm not aggregating totals by month. In this case, I'm simply saying run this range query and give me back. But when I ran that range query, I still had to decide my input values, right? So I'm still binding the query here to a particular time zone, in this case UTC, which is time span 0, basically. So it's saying it's right at the 0 mark. If I was actually running this on behalf of a particular person, I would want to know the time zone of the person I was running it for. What is their expectation? I'm going to do those conversions and run that boundary based on their expectations, not based on my understanding as a developer. Possibly. So it really depends on, so like one thing people do in sales specifically is they tend to be often regional. So if you have a West Coast regional salesperson, they may still want to see their report totals aligned to the West Coast. Then if you just because they're traveling on the East Coast doesn't mean that they change their perspective on the reports that they're running. So that's where I say you got to get a little more thought. What's the right time zone to use? It might be the local time zone of the machine, of the computer that is making the call, or it might actually come from some piece of data that you've saved in your domain if you've got a richer domain about how time works within your company. There is no exact one right answer. An interesting thought exercise is on blog posts. So if you've ever looked at a blog post and it says, instead of the time, it'll say something like 3 hours ago, that's a very good way to represent that, because then I can just store everything as UTC, and it doesn't matter what your time zone is that you're looking at it. But if I want to say what were all my blog posts for yesterday, or if you're saying I wrote this thing at 3 p.m., you better somehow align that to my own time zone. Otherwise, I'm going to get information that doesn't make sense to me. So I would recommend you put yourself through those thought exercises of what does time mean for the observer of my data. Okay, so when I ran this, I said, give me the time, and if you notice, I actually, well, on this one I'm passing in 0, so that's not actually the best example. Maybe I can, 31241. So again, it's a tick before this, and that's because of the right brackets that's being used, so it's non-inclusive. Let me go down to the end, and hopefully, if I ran this a couple more times, this is random data. Oh, wait, here's one right here. You notice they don't seem like they're in order as you're coming down. I'm like, well, wait a minute, they're in order not by the time zone of the display output, but here they're in order by the time they actually occurred. So I have one that looks like it came later because of 331, but if you look at the offsets here, this one's plus 14 and this one's minus 2. So actually they are incorrect sequence from a time ordering perspective, even though the data looks like it's out of sequence. Also, the range I specified should have been over at 4.1, right? But only at 4.1 UTC, not necessarily at 4.1 in their local time. So that's why I'm saying the boundaries get fuzzy. You have to have some perspective to apply. Let's move on. I've got a handful of these. I've still got, how much time? Okay, that's great. So here's another case. Again, I'm storing datetime offset. Datetime offset is probably going to be the best data type that .NET has to offer when you're storing things that are coming from users. If they're not coming from users, if they're being generated by you, then you might consider a UTC datetime. But if somewhere in here there's a user involved, which in this case there's a customer who placed the order. So even if I'm taking my own clock, I'm still taking the perspective of that customer. I probably want the datetime offset. And here's a case where I am doing aggregations by time zone. So this is what I wanted to show you, I think. Let's see here. Okay, so in this case, I'm aggregating by the datetime offset's date. So even though the datetime offset is variable, I'm using the customer's date portion of that. So this would be a report that I could give back to the customer to show them their groupings by day. It's going to have slightly different boundaries than something I would normalize to a particular time zone. I'll just run through that. I just threw a bunch of samples together to show you different approaches. Where is it? Oh, there it is. OK. So here, it's aggregated by date, and I must have forgotten the order. Oh, I'm in reverse order. OK. 9, 8, 7, 6. So these are my last 10 days past. And notice there's no offset or Z or anything at the end. And really, they're all zeros. So what I'd really like to have in my data is something that doesn't have those zeros. Because this is where I was saying where the DateTime object is lying to you. It's not the time at midnight in some local time zone. It's the entire day that I'm representing here. Your context boundary is wrong. Now, fortunately, I do have an example that can do that. I'm going to show you the result before I show you the code. It's exactly the same as this last one. But when it runs, there we go. This is what I'd like this data to represent. It's more contextually accurate to just say that this is the count for that date, for the entire date, not for midnight on that specific point, right? So how did I do that? Anybody have an idea? Noda Time. You can tell by the end. So Noda Time is, I'll pull it up real quick, nodatime.org. So Noda Time is a better date and time API for .NET. Primary author on this is John Skeet, who's very famous for his work on C#, written many books on C#, lots of Stack Overflow stuff. You can go read all you want about him. The concepts for Noda Time came from a Java project called Joda Time. But Skeet's pretty smart, and he works in Java and in C#, and he realized there were some fundamental issues, or not really issues, but more inaccuracies with the way Joda Time was rendered. So he made some changes to make it more friendly for .NET. And to make it really represent things properly. We did such a good job that the original author of Joda Time, a gentleman named Stephen Colborn, looked at what John Skeet had written and said, that's pretty good. And by the way, I'm working on this new thing for Java. Actually, it was just published a couple weeks ago. In the Java 8 runtime, there's a new system.time namespace, which looks pretty similar to Noda Time more than it does to Joda Time, even though it was written by the Joda Time author. So that's really interesting, kind of full circle. But basically, you get different types for things. So this is the example on this site. Instead of saying it's a UTC date time, we just say, well, what are we talking about? We're talking about an instant in time, so I want an instant. I don't get it by calling DateTime.Now or DateTime UTC now. I specifically wire up an instance of a clock object, in this case, the system clock. It could be a fake clock if I'm doing testing. And when I say .now, I know that it's that instant now. We have different objects here, like a zone date time is a date time in a specific time zone. It's more rich than date time offset. And there's a whole bunch of other things, too. I'm not going to teach you about Noda Time here, but I just wanted to show you what it is, and you can go look at the website if you want to know more about it. What I can do is I can now use Noda Time types in my objects. Here I'm not using a whole lot more than offset date time, which is like date time offset in concept, but it's slightly different under the hood. I'm using that for date order. And in my index, I am returning a result that uses something called a local date. So there's a slightly different context of local here. Local in Noda Time means local somewhere. It just means it's on a local calendar. It does not mean it's tied to the local time zone of the computer it's running on. When you see local on DateTime, where you say kind local or DateTime.Now, that means the computer it's running on. This doesn't mean that. But this gives me exactly what I want. It's just a year, month, date. So that's the right type for the results. It's in the right shape. All I need now is JSON serialization. And that's something that I've authored as an open source project. You can go to GitHub and RavenDB.NodaTime. And you can find RavenDB support for Noda Time. And there's documentation and a NuGet package. And you can basically just plug it in, and it works. How it works is something I'm going to talk a little bit more about in my second demo on extending RavenDB. Even if you're not interested in Noda Time, you might be interested in how this kind of stuff is wired up. From the perspective of this demo, basically I have one line that says configure for Noda Time. And there's two pieces to it. There's a piece that happens on the client side, And then because I needed Noda Time types in the index itself, there's a bundle that I put on the server side as well. If I didn't need things in an index, I could do all of this just on the client. And again, I'll talk about that more in the second demo. From there on out, it's pretty much the same. I still query in the same way. I'm not using DateTime anymore. I'm using instance. But I can plug them into my application exact same way, and I get all the richness of Noda Time. So here I can say, I would like a time zone. And in this case, I'm using the IANA time zones, not the Microsoft time zones. Noda Time actually gives you access to both. And I'm applying, this isn't populating this random data, so I'm basically saying from all over the world in random data, and instead of using DateTime offset, I'm using Noda Time's offset DateTime, and everything just works. Again, the net advantage just in this one demo is a little bit hard to see the worth, because you could just say, well, I'll just ignore the zeros. You might be tempted to think, well, why do I have to do Noda Time at all? If all I want to do is get rid of the zeros, why can't I do toString, year, month, day, and call it done? I'll just store everything as a string. The problem is, and I hate to pick on Oren, but the way that Raven internally understands its types, it does pattern matching. And if the server sees a string that looks like a date, it will try to deserialize it as a date time. And if you're doing toString and you throw the zeros away, and then you basically RavenDB will reintroduce them when you come back for your query. There's some other little nuances in the way that serialization and JSONnet are wired into RavenDB, and it's very, very nuanced, but it does cause leaky little problems. So through Raven's extensibility infrastructure, I'm able to take a type that's already created for this purpose and just use it. That's the net takeaway. Any questions on that before I move on? OK, I'm going to go through a couple more of these demos. So here I want to show, this is not using Noda Time, but I'm going to show doing queries in a particular time zone. So notice I have a different index here. Instead of just sales order totals by day, it's sales order totals by day in the US Eastern time zone. This is where you get to, I have a salesperson who works in a particular region, and they're boxed into that region, right? That's one way you could divide up your sales group, is by the time zones that they work in. That often does tend to be the case because of how people set their work hours. They arrive in time to meet a particular destination customer's area. I worked in a call center once, or for a company that had call center, and they would have people that had to get in really early in order to make, on the West Coast, to be able to answer calls from people coming in on the East Coast. And they had people who worked overnight, so they'd be in the local time zone of people overseas. So if you have that going on in your company, you'll probably need to be dealing with time zone conversions somewhere. And in RavenDB, you can do that right in the index. Without any plugins, you get full access to the system namespace in .NET, and one of those objects in .NET is time zone info. So if you're using the Microsoft time zones, again, this Eastern Standard Time just means Eastern Time, so just logically pretend it says Eastern Time. You'll be better off for it. And I'm going to take that date and I'm going to convert it, and that's what I'm indexing. So I'm not indexing the original value I had, I'm indexing a converted value. And then I can do all my aggregations on that, and everything works out great. I'm not going to bother running these or we'll run out of time. I also wanted to show that you can do that with Noda Time. So this is very similar, except here I'm using American New York, which is the IANA zone. And I'm in an index, and because I'm not using something that's shipped with Raven, and it's running on the server, this has to go in a bundle. So if you don't have access to the server infrastructure, maybe you're running in Raven HQ, then you won't be able to do this part of it. But you still can use the Raven client Noda Time integration to not do this kind of aggregation on the server side, but you can do some of the things on the client side. It's only when you're in a static index that you have to have this access to the server bundle. So Noda Time has this in-zone method, and then I specify the zone that I want. I got that zone out by specifying a particular provider. If I wanted to use Noda Time for Microsoft zones, there's a BCL provider, and then I would put Eastern Standard Time in here. But if I'm going to do that, I might as well just use time zone info, which comes with .NET. You may see some weirdness like this .resolve. It's not what we're talking about here. Also this toInstant, well, it's already an instant. Actually, in that case, it's not. But this has to do more about how Raven's pattern matching works and how to defeat it for a particular reason. So if you want to read more about that, you can go to the documentation on my blog and do it. But needless to say, this gives me back what I want. Let's just run one so that we have an example case. By the way, I'm doing all of these in Raven test helpers, which is this really nice package that kind of bundles XUnit and a bunch of stuff that these guys have written into something that makes it very, very easy to write a unit test. I don't know if you noticed, I don't have .initialize anywhere on here, and all these are in-memory stores, and I've got some helper methods and other things in it. It just makes it really easy to start doing stuff and not worry about where it's stored for sake of either demo or for sake of delivering a bug report to these guys if you need it. So again, here I'm using whole dates. That's that local date. And it's maybe not apparent in the results other than the fact that it did an error, but it converted to the time zone, it converted that big date time offset to the target time zone I specified, and then took the date of that time zone and then aggregated on that. That gives me daily reports that are in this US Eastern time zone, regardless of where the source data came from. And a few more minutes. This one does almost the same thing, but using the customer's time zone. So where do I get the customer's time zone? Well, if you remember when I populated the order, I set it. So it's actually somewhere in the customer's object somewhere. But in this demo, I'm not showing you a customer object. I'm just showing you that date time offset. So if you don't have Eastern Standard Time written somewhere in your classes, but you do have date time offset, you can infer that that offset was created for that time zone. So if I just want to aggregate this point in time, I basically am just ignoring the offset. I'm basically saying, okay, look at date time offset, strip off the offset, and index the rest of that. And that basically is doing it by, here in this tour, I'm doing by week and hour in the customer's time zone. So what I'm really after here are like, what are the most popular hours of the day on a particular week? So do I do more sales when the customer is in their waking hours of their morning on a weekend? Or maybe I'm a restaurant and I do more sales in the customer's time zone. Maybe I've got locations all over the world, so this is important to me. But it's not about the time zone in my headquarters, about what was the busiest bar sales in the restaurant. It's more about what was the restaurant's time, and I want to aggregate based on that. Again, we'll run this. All these things you can do with or without Noda Time. Noda Time makes it easier once you get used to Noda Time. So don't think you have to use Noda Time to have good date time representation. It just means there's more hoops and wire up, but then it becomes easier in your thought processes. There's a trade-off. So here, this is saying, I'm sorting here by the total. So this is saying, I generate random data, so it's probably not very accurate. But my busiest time was Sunday, in the 3 o'clock p.m. hour, where I had 23 sales that equated, in this case, to $12,000, an average sale of $500, et cetera. So those are the kinds of reports that you can actually get out of RavenDB aggregations. And the only reason it took any time to run at all is because I'm doing all of this live. So I've got tens of thousands of records that I'm storing, aggregating, and reporting back to you on, all based on MapReduce and just a little bit of thought into what is it I actually want to represent. If you're doing this on a live system, it's much, much faster because you're only updating a little tiny bit at a time as new things come in. It's got a lot more time to work, right? Because it's happening in real time. So a lot of people say, well, RavenDB is not good at reporting. It actually is pretty good at reporting, as long as you have an idea of what kind of reports you want out of it to start with. In that regard, it's way better than SQL Server or anything else that does that it has to do dynamic reporting. Raven can do dynamic reporting now, but it doesn't have to. If you have pre-canned things you want to run all the time, it makes sense to set them up as MapReduce indexes and just give it a little bit of thought into how you want to bucket these periods of time. Here, this is an hourly total by day of week. That's a particular bucket that I've set up to throw orders into so that they're aggregated and I can report back on them. Let me see if any of these others are worth talking about. No. OK, I want to show you something kind of crazy. And this is definitely a don't follow my example, but I want to show you what's possible. OK, we've heard a couple times about watch out for load document and for fan out queries. I'm going to show you. I'm going to actually do that. So cover your eyes or don't. But I want to show you how interesting this can get. And this all uses Noda Time. So I'm going to run through this demo real quick, and this is the last one I have. Basically, I've got a very small model. This is the entire model. I've got a business that has a schedule of operating hours. And that schedule has the ability to change. I can say from this date to this date, my hours by day of week are from this time to this time. That's actually very common with restaurants and other things, that retail sales that has opening and closing times. This particular model won't hold up very well if you open and close lots of times throughout the day, or if you have like a lunch shift in the middle of the day. You would need to expand on this. But the way that I've modeled this is I've got basically two top-level documents. I've got businesses and I've got schedules. The schedule itself is more complicated. I've turned the time zone of the business, the actual location. So this isn't a nationwide or international business. This is a specific business location that has a time zone. And then I've got a schedule, and the schedule is tied to the business by its business ID. And I have a from date and a to date that the schedule is in effect. I'm using Noda Time's local date class to represent that because that's the best use of that object. And then I've got a list of hours for that day. You'll notice I initialize my list with concrete types. That makes it a lot easier in the C# code to say things like just new it up and then .add. Doesn't affect anything else. I could leave it off and it would work as long as I'm initializing the list from serialization or in its entirety. But I usually have the habit of initializing my list objects. I also tend to like using interfaces like iList. You don't have to do that. You could just say that it's a list. But that's just my preference. Hours of operation. Okay, I've got some other weird classes that may look strange to you. Talked earlier about a time span is not a time of day. Well, a Noda Time local time object is. It's exactly that. It represents a time of day in some local time zone somewhere. In this case, I don't need to know which time zone it is because the time zone is timed back to that business. I just need to know that within this data structure, I've got a time. I also have ISO day of week. It's kind of like .NET's day of week class, except that would work, except Noda Time's, the rest of the Noda Time infrastructure uses the ISO day of week. The only difference between the two is that Sunday is 7 on the ISO scale instead of 0. It's all just how you handle the enum. For us, it doesn't really matter. It could be either one. We actually like to treat things as strings in JSON. You can store enums as integers. I don't recommend it because it kind of defeats the purpose of being an enum. I like to store enums as strings so that when I'm reading my JSON document, I actually can see what it represents and it has meaning. Personal preference. So let's see what we're going to do. Well, I'm going to populate. This is the high level. I'm going to set up Noda Time. So configure for Noda Time. This is just a call into my library to run all the extension methods need to wire it up to Raven. And I'm going to dig into that specifically in the next talk. I'm going to create the index. I know not all of you are familiar with this syntax, but this is the one I recommend personally for unit tests. There's one slightly other way to do this, which is also valid, which is new schedules index. And then I believe it's .execute. Those are equivalent as far as I know. Correct me if I'm wrong.
There's minor differences if you use
Sharding, thank you. Minor differences if you use sharding, was what Warren said. You might be more familiar with create, what was it, index creation? Yeah. Create indexes, and then you pass it the assembly, right? I don't recommend that for unit tests. Because what will happen is it'll find indexes that are defined in other tests and put them into the database you're using for this test. In unit tests, if you want an in-memory document store, like I'm using with the test helpers, you really don't want it scanning anything. You want to be very specific about which indexes you're testing. So creating an index, adding some items, which I'll show you in a little bit. The test helpers gives me this nice wait for indexing class. Now this is very optional. Another way to do it would be to say, customize. I have to do it one level up. I'm sure many of you have seen this. Customize x.wait for non-stale results, right? So I can do either one of those. That's optional. You never want to do either of those in real life. It's just for unit testing. It's important for unit testing because I'm writing the data and I'm immediately querying it. So if I don't give it some time to actually work in the background, I'm not going to get the results that I'm expecting. Then I got this nice other little one, which I really like. Wait for user to continue the test. It's got 2 modes, so make sure you don't call it without passing the document store. The other mode is for when you actually have an HTTP server. In this case, I'm an embedded document store, but I'm going to spin up an HTTP server in order to wait for the user. I'll show you that one in a minute, but basically it gives you, in runtime, it lets the test just run right through it, and at debug time, it launches the studio for you, and it pauses at that point. So you get a nice, like, what's going on right now? Let me see this in the studio to figure that out. So really all I'm doing is I'm saving some data and then I'm querying it, right? But what am I querying? I'm querying back hours for date. Let me show you that object. So this is a projection that I'm going to fan out to create. Yeah. So what am I after here? What I'm ultimately after is I want to query my index to say, what restaurants are open right now? That's the net result that I'm after. I want my database to tell me if I have, I'm only going to populate one location here, but if I had lots and lots of locations in all different time zones all over the world, please tell me everybody that's open right now. And I can do this all in the RavenDB index, and even though I'm spending a little bit of time fanning out, I'm really only having to fan out 1 day per location because I'm scheduling by day. So it's not tens of thousands of items it creates. One business will create 365 items per year. In this particular case, I'm scheduling 2 years worth. So it's not the most horrible thing you could do, but it's probably not what you really want to do. What you probably really want to do is do some of this in your C# code and pre-calculate that stuff and then save it into the database in a different type of a document. I'm specifically doing it here because I want to show you what's possible in an index, if that makes sense. I can see your eyes rolling.
Go down, please.
So here's my index. So this is using Noda Time, and you can see lots of lets. Sorry about the mic. I think I'm tripped on the wire here. There we go. And basically what's going to happen, I'm using load document to pull in the business's time zone. And while I'm there, I'm grabbing the name just for output. Probably don't need the name in this result, but I wanted to show you in the projection. I need the business's time zone. If you remember back on my model, I stored it. I'll scroll back there in a second, but I stored it up here with the business. Okay. I'm then specifically on the schedule using the from date and the to date of the schedule, and I'm calculating how many days are in that period. Hold on a second, I gotta fix this because it's pulling on the chair here. Sorry. You still hear me? Okay. So, again, these are about defeating the serialization stuff, and they come with the Noda Time bundle. So basically, I've got some methods in here that you're not used to seeing. I'm in an index, but I'm calling things that aren't provided by Raven or by .NET. And in this case, it's not even provided by Noda Time. It's provided by my own code, which may sound a little scary, but it's actually quite easy to do. And I'm going to show you that in more detail in the next demo. What it does specifically isn't important here, other than to know that I need to call it in order to treat this as a Noda Time value. What's actually serialized in this document, the way Raven sees it, is a DateTime. But the way that .NET sees it as a local date. So this is a little hint to the index to tell it, as you're evaluating this information, please treat it as a Noda Time local date object. I would love it if I did not have to do that, but I do. So, because in theory, I should just be able to leave all those off. If everything still compiles, it should function, but I'll get an error at time it runs. So how am I fanning out? I'm calculating how many days are in between these things. Days between is a little extension method I wrote because the Noda Time way to do that is a little more complex than I want to write here. So again, this is an extension method that comes with the Noda Time for RavenDB plugin that is understood by both the client and the server. And here's the big fan out. Enumerable range, and I'm saying I want a new day for every date in that period. So if I started with from and to, I'm going to get a new day object for every one in between. That makes sense. It's not a huge fan out as long as I'm controlling the range of that period. But in theory, I could typo and put in like the dawn of time, and I'd have 20,000 items in my index, and then I would get a call from my DevOps person or my ops person who's watching what's going on and say, "Hey, what's wrong with you?" I ran this in the current 3.0 beta. This is running in 2.5 right now, but I did try against 3.0 and it works. So this is probably one of the most complicated indexes that you'll see because I'm doing a lot of business logic in here. No? You've seen worse?
I wish it was one of the more complex. I have user send me indexes that goes on for scroll and scroll and scroll.
It's a lot better than a stored procedure, at least. I can refactor this easily, and I can see it all on one screen. There's another little bit of weirdness in that enums do fail, so I have to do string comparison. Both of these are enums, even though they're different enums. I should be able to convert those. Oh, I'm sorry. This is the property, and it's the property is called day of week, but it's the ISO day of week type. So they are the same enums, so I really should be able to pull off both of these two strings, and it should work. But I will get a compilation extension because the Raven index sees the string serialization of the enum and tries to compare my real enum against a string, and I get a type mismatch. So putting to string on both solves that problem. Here I'm creating, basically, as I'm walking through this, I'm starting with the from and to date in my schedule, and I'm saying fan out for every day in that schedule, and then I would like to calculate an opening time and a closing time for each date. And ultimately, that's what I'm indexing. Other than the items that I pulled in, I'm saying, please store on that date the time that they open and store the time that they close. I'm storing these in the local time just for reference. I could comment them out. What I'm really after is these ones. I'm storing these as actual UTC instance. So that allows me to do that comparison and say, I would like this result to have the instantaneous time regardless of where I am on the planet. That way I can say, where are all of the locations that I'm currently interested in? Now, because I'm doing all these as projection, I make sure I call store all fields. That puts all the items in the database. There's one other little bit at the bottom, and sometimes I put this at the bottom and sometimes at the top. For embedded RavenDB, if you want to wire up a bundle, you have to manually add it to the catalogs. This is the equivalent of taking my bundle DL and dropping it in the plugins folder. I'm doing this in modified configuration. This is an override that comes with the base class, the Raven Test Helper base class that I'm using. Right here, Raven Test Base, comes from Raven Test Helpers. The modified configuration gives you a chance to attach additional items to the configuration catalog, which is what's normally read from the plugins folder. In a live system, if I wanted to use my bundle, I would not use this method. I would specifically drop it in the plugins folder and let Raven discover it. And if I wasn't using Raven Test Helper, I would do this, but I wouldn't do it in modified configuration. I would do it just before initialization as I'm wiring up the embedded document store. So let's run it, see if it crashes. Demo time. So let's see here. Oh, I got two tests, actually. So this one is just saying, this is what I was after, right? I would like to query, notice the range query here. Let me just show you the C# code for this. This did work. It showed me what was open. The C# query is, well, there's populating. I don't care about populating. OK, so this is for a particular moment in time. I'm saying, please take now, and here's my range query, right? And again, here's the half open interval. I want all items back that the opening time is less than or before now. So I'm in the middle of this range. I want to say right now, greater or less than or equal to on this side, and greater than on the other side. You have to think about these when you write these ranges, because based on which way you're comparing it, you might be flipping these signs. But you're always going to do, when there's time involved, you're always going to put the equals on the left side, never on the right. Only when time is not involved and you're querying by whole dates would you put an equal sign on the right. The other test that I have in here is giving me back all scheduled dates. So I really want you to see what's in the index, right?
And I'm gonna, well, let me show you this one first that it worked. So this is what I got back. I got the business time, and I got back the specific local open and local close. Now what's interesting here is that there's no Z or offset. These are local times. It's like I had date time unspecified. In this case, it's a Noda Time local date time. But it is the specific day that I'm working on, which is today actually, 4/8. And I am open from 11 a.m. to 10 p.m. on this particular date. But in UTC, it's actually even crossing the day boundary here. From today until tomorrow, UTC, it's 1600 and 300. So the time zone has already been applied. So when I actually query, I'm just querying the value between these 2 points. Make sense? Let's just go look and see what's in the actual database. I'm going to do the debug. When I'm in debug, it's going to hit that wait for user to continue test, and it's hopefully going to launch the studio for me. This is in 2.5 right now. I had it working on 3.0, and then I had a little problem, so I put it back to 2.5. So sorry for the silver light. But you'll see once it comes up here, I should have 2 schedules for the business. These are the business schedules that I created. Let me go to extra large so you can see. So I'm saying business 1, and I've got the 2013 schedule, and I've got, once I scroll down to the bottom, hopefully it's open, or the 2013 schedule, and then I've got the 2014 schedule in a different item. So this is saying these are the dates the schedule is valid, and there's my business hours day of week. So this is modeled actually pretty good. I would actually, this particular model for here is not bad. It's only the fan out that I wouldn't really do in production. Because what I'm serializing to could actually be done in the business objects themselves. You'll see the fan out here if I actually go to the index that we built, that gnarly index. You see there's 728 items. Even though I'm only storing 1 business, I've got 2 years worth of information. And I don't even want anything on here. I'm just going to execute that, and then I'm going to, yes, that's actually what I wanted to see, index entries. So query options, index entries is showing me all the things that were built. And you can see for this one business, even for this one schedule, I've got all these different items, but they've been changed, they've been fanned out by the day of the year. So that does set my data up right, but I probably should be doing this work in a different place in my application. But it's certainly possible to do in an index. I would even argue, if you don't have thousands of records, if this is something you've got 10 locations and you're changing schedules once a year, 700 items isn't that much for Raven to work with. Raven can work with indexes with millions of entries. And in this particular case, it's not likely the time zone of the company or the name of the company is going to change. So it's probably not the worst thing you could do. But it's still not a practice you want to get in the habit, and I just kind of want to show you that you can use all these different types, and they represent different things, and they can be used at query time, and they can be used at index time, et cetera, et cetera. And that's all I got. So are there any questions? Yes?
Method or extension method, I saw.
Uh-huh.
Where is there notice?
Sure. So InZone has 3 flavors, and this is specifically in Noda Time. So InZone by itself requires that you tell it what to do in the case of a daylight saving time ambiguous point. So it leniently says, do what you think should be done, and it picks one of 3 different behaviors by default. It's kind of what .NET does if you try to convert either an ambiguous or an invalid local time back to UTC. It lines up with that. There's also one that's in zone strictly, and what it'll do is if you give it data that doesn't make sense or isn't immediately clear, it'll throw an exception. So you would trap that exception and then do what you want. In zone by itself will take a delegate and you pass it a class as behavior. I have not tried that particular one in Raven yet, but in theory it should be able to work. Yes?
Like you said, these time code rules didn't change. Do you know how Noda Time is going about issuing updates to the
Yeah. So Noda Time ships with an embedded resource of all the data. And it also has, I don't know if you saw in there, I said DateTime source providers, and then I just told it to use the default TZDB provider. I could actually pass there a reference to a file and say load it myself. So you can deliver to your data, and probably you could deserialize it into Raven. You could probably create a class that actually stored it in your database, and you could just update the data bit from there. You would have to build those things. Out of the box, Raven just gives you a builder that gives you an XML file, or actually it's more like this compressed binary that you pass in. But you can update it whenever you like, absolutely. And you probably should have some ops cycle for that if you're international. Then you can avoid the things like missing in the hour webinar. Anybody else?
So in this case, for the, we have web service, right, to handle the business process.
Mhm.
So for the server itself, it doesn't matter what time zone you set up.
Exactly.
So we just read some information from configuration saying what time zone this service is going to use.
Mhm. The best practice advice I can give you there is the clock of your server should be synchronized, but the time zone should not matter. There are programs that don't do time zone handling properly, and that's why there's often a recommendation that servers should be set to UTC. But if your app is constructed properly, you should never ask the computer for its local time zone. So I see a lot of questions like, well, my server's in New York and my company's in India. It really shouldn't matter where your server is. Try to design your application so that you can pick your server up along with the data, move it somewhere else, and it still works, and your data is still good.
Good.
Storing UTC.
Mhm.
Is there any particular role that you know about with that approach?
Yes.
If I take a user time zone into consideration?
Yes.
Like where?
Yes. Without spending too much time, feel free to talk to me about it afterwards. The biggest mistake in that area is when you're scheduling future events. If you're building out a calendar, especially one with cyclical events, so you've got a recurrence, something happens every day, just think about your daily alarm clock, that really should not be stored in UTC. That should be stored with local perspective to a particular local time, and you have to have rules involved, you have to deal with time zone updates, and it gets really complicated really fast.
Part of this, we are running the similar situation. Clock out of multiple time zone. Native support is very challenging
Mhm.
because we have to set up different time zone server for different time zone. So
Because the application is dependent on the time zone, so you
it's
have to set up a new one for each time zone.
yeah, because of the time, that time offset,
Uh-huh.
of course the information is correct.
Yeah.
But to display or use that, it's always changing.
Yes.
But with this, I think it's a lot of problems.
Yep. The key takeaway is think about it more than just it's a data type. It's not as simple as an int. People throw it in that bucket because it's in the system namespace and it's a value object. I got int and double and date time. Don't think about it like that. It's a small little miniature domain, and it's got its own set of nuances, and it participates in your domain in a very specific way. So from a contextual perspective, understand that domain before you just start using it. On a daily alarm, you need the time of the alarm. You don't need a date because it's a daily thing. You need their time zone that you want to fire in, and you need a rule that's probably something you define that says, what do I do in an ambiguous or an invalid scenario? Typically, the rule for ambiguous is skip forward, because if, say, you've got something that fires at 2 a.m. every day, well, when we bring forward, we go from 1 to 3, or 1:59 to 3, so we don't hit 2 a.m. So when should you fire that alarm? Probably 3 a.m. because 2 a.m. didn't happen. And in the ambiguous time, you hit 2 a.m. twice, you probably don't want your alarm to go off twice. You probably want it to go off the first time. But that's just on like a daily alarm clock. The scenario will demand that the rules be different depending upon what the scenario is.
You effectively have to do a calculation similar to your fan-out example.
Yes.
Determine the instant each day.
You can do it in memory, or you can have a daily batch job that sets those instances up ahead of time. That would be more code than I could demo, but that's ideally what you'd want to do. Okay. Thank you. Hope I didn't bore you to tears.